So please confirm that you can see my screen, and then I will start. Okay. So let me go to the the course page on my website. So far we have covered HDFS in detail. And if you have any questions on HDFS, we can take towards the end of the class. And after the HDFS, we started on MapReduce. So I hope you have the development environment already. If you run into any issues, let me know again towards the end of the class, and I will try to resolve the issue. And now we will actually get into the details about how to develop the MapReduce program. I will also cover the framework aspects, but I will not get into too many details about the framework because it will take too much of time, and the major component of the course is Spark and Hive as well as Scoop rather than MapReduce. As the MapReduce is fading out, I don't want to emphasize a lot on the MapReduce as part of this class. I will just give the overview about how to write the programs and how it executes as well. Okay, so just give me a moment. I will get the tablet so that I can do the whiteboarding. I forgot to bring that. I will be back in a moment. So I'm back. I am connecting the device, and then it is required to do the whiteboarding while explaining the MapReduce framework. Okay, now I'm starting the software so that I can draw. So if you think about any of the typical transformations in any of the projects, whether it is a traditional data warehousing or even in the OLTP also, if you have to do some batch processing. 1 minute, I forgot to send a WebEx invitation to one of the student. I thought I have sent. Let me share the details with him, and I will start. Okay. So WebEx web dot. I already have here. I just have to invite another guy. How to do that? Okay, I don't know how to invite him. Probably I have to send this link to him. Okay, we will wait for him for a minute. and then we will start. Okay, so we will wait for him. I hope I will just give 2 minutes and we will start. Sorry for that. Sorry for the confusion. He just asked me to add him yesterday, and I forgot to add him to the WebEx invitation. So he didn't get the invitation. So it's he just pinged me on WhatsApp, and I sent the information to him. We will just wait for a couple of minutes, and then we will start. Pardon me? Yeah, yeah, we can take the question, but you are barely audible. Can you talk a little bit louder?
Is this any better?
Yeah, a little bit better. You can go ahead.
Just going back to that basic concept of the local file system versus the HDFS.
Uh-huh.
So if I have a single node, just hypothetically, if I have a single node cluster, right, where my master node and my data node, everything is on just one single box.
Yes.
One single box.
Yes.
My local file system is basically when I'm in my Linux shell, that is my local file system.
Yes.
And then my HDFS is wherever I have the Hadoop installed. Is that correct?
So when you set up the Hadoop, even if it is a single node cluster, you have to give that data node directory and name node directory. Okay. And whatever files you save into HDFS, the files will go to that location, which is configured as data node directory in the form of blocks. Even on the single node cluster also, data will be stored as blocks only, and they will be physically present on the location which is configured for data node directory. Okay, so the behavior will be same. Only thing is both your local file system from where you are trying to copy the files and the HDFS location will be on the same physical server, but the way it manages itself is same whether you have a single node cluster or a multi-node cluster. Okay, I will show you actually. So I'm starting the VM. Okay, it's a it's a Cloudera VM. And then I'm going to the terminal. Yeah. Okay, now if I go to etc Hadoop conf, and if I go to hdfsi.xml, there will be a directory. Okay, I think it uses the default location somewhere. Okay, so typical, I think it is something like this. So Cloudera, it will hide some information internally, and unless you go through the browser, you will not get the actual data directory. So, but it uses the location like this. I will show you that. So cd var lib. Let me do head hdfsi.xml. Now cd var lib Hadoop HDFS cache HDFS TFS ls-ltr. So you have data name and name secondary. So this is the one which is configured as data directory. If you have the Cloudera manager, you can see that by looking for the parameter. And then under this, you have the actual files. actual data in the form of blocks, the same way we see in the multi-node cluster. But these blocks can be accessible only through Hadoop SS command. Okay, whatever is in HDFS can be accessible in readable format either by using Hadoop SS command or APIs to process the data in MapReduce. You can read this data. Okay, only through going through the name node you can get actual meaningful information from these files, which are stored physically in the form of blocks. That's why the actual files are logical, they are not physical. You don't find with the name you are trying to copy into HDFS if you search on any of the nodes, because it internally converts into files something like this, and it will store using the naming convention which starts with BLK underscore and then unique ID. Okay, whether it is multi-node cluster or single node cluster, is the same. Yeah. Okay.
Just one question. You said your actual file is virtual.
Logical.
But these BLK, but these blocks are nothing but files.
Yeah, they are physical files. So a logical file will be divided into blocks, and a block ID will be associated with it to give a naming convention. And using that naming convention, those blocks will be stored physically on the nodes which are designated as data nodes.
All right, this is helpful.
Okay. I think my daughter sucked this headset, and that could be the reason why it is not very audible when others speak to me. Anyway, now I think Ajay might have joined the class. Let me see. No, he didn't join yet. Let me ping him and then we will start. Okay, so we will start. So now we are getting into the MapReduce concepts. So first of all, let's take, okay, there is a question. When I type the command in a single line, it does not work. In scoop options file, options to be very picky about how to type the command. Also, what is a cumulo? So we will look into this question later, Nagraj. So now let us move on to the MapReduce. So first of all, let us understand what are the typical transformations we do. So if you think about a query, when you try to access the data, typically you filter the data by using where condition. You group by and do some aggregations, and you do sorting as well as joins. These are the typical transformations you do with any database, be it Oracle or Teradata or any database to process the data. These are the transformations you do. One is filtering by using the where clause. Second one is row level transformations, like standardizing the values in the rows. For example, you are getting address from multiple systems, and in each system they might have represented. Yes, Ajay, we just started. We waited for you for some time. We just started. We are getting into the MapReduce concepts. Okay, if you have any questions, you can unmute yourself and you can ask the questions. I have muted you on the entry itself, so if you are speaking, we cannot hear you. Okay, so now yes. So now the first one is filtering. Second one is the standardization of the data, row level transformations, such as addresses. Addresses can be in different cases in different source systems. And when we typically copy the data into downstream applications, we tend to standardize the data either into uppercase or lowercase, whatever we think is the most appropriate one to run the aggregations at the downstream systems, which is typically applied in the select clause if you write in a query. 1 minute. Probably he might not be able to hear me. And the third one is you group the data, do the aggregations such as sum, average, min, max, etc. And fourth one is joins. So these are the typical aggregations you do. So when it comes to MapReduce, so MapReduce is nothing but a framework. You have to do certain type of tasks in map function and certain types of tasks in a reduce function. And before getting into the details, MapReduce. Okay. It seems he cannot hear my voice. So when it comes to MapReduce, you have to perform certain types of tasks in map function, certain types of tasks in the reduce function. So what type of tasks you should perform in the map function? So map function is typically before getting into the details, you need to understand how the map function and reduce function are executed. So I will take a simple example, which is called card count by. Let me change the pencil style here. So card count by suite. So what is this card? They are nothing but playing cards. So if you are familiar with playing cards, each deck will have 52 cards. You will have two colors, red and black, and then four suites, two colors, four suites. Those suites are nothing but spade, heart, diamond, and club. Those are the suites. And then the third one is pip, which are nothing but 2 to 10, and J, Q, K, and As or A. So now let's say you want to get the count by suite, okay? And if, when you represent that kind of data in files within a file system, typically the data have a structure. It has three fields for each record, and first field is color, second field is suite, or you can change the order of these fields, but it should have three fields. In my case, it's color, suite, and pip. Okay, and each record you will save the color. It means you will have the color, you will have the suite, heart, and pip. Similarly, red, heart, another one, three, so on. Okay, so and when you actually store in a flat file, you will have a delimiter in these fields. So let's take the example of pipe as the delimiter. So each record have three fields, and these fields are delimited by pipe. So now if I want to get, let's say, card count by suite, okay, so first I need to pass each of these record, right? And I have to get the suite, and then I have to aggregate by suite to see how many hearts are there, how many clubs are there, how many spades are there, and how many diamonds are there. Okay, so I will take the example of a very large deck. I have to change the device again here. Okay, here I am taking very large deck. Okay, let's say this is 1 GB. And first let us understand how the data will be stored in HDFS. Okay, so you have multiple nodes in the cluster, which are data nodes. Here I am only representing data nodes. Let's say we have 4 data nodes. And let's say our block size is 128 MB and replication factor is 1. So what will happen? This 1 GB file system, 1 GB deck of cards will be divided into 8 blocks. Okay, and each block will go to these nodes in the cluster. As we have 4, each one of them will get on average 2. So block 1 and block 2 might go to this data node. Block 3 and block 4 might go to this data node. Block 5 and block 8 might go to this data node. And block 6 and block 7 might go to this data node. Okay, now data is distributed like this, and when we try to process the data while implementing the map function, what we need to do is first we need to understand how the map will execute. So when we actually submit the job, typically the mappers will be created based upon the block size. So for each 128 MB, a new map task will be created. So there could be a map task to process the data block 1 by default. You can change the behavior a little bit, which I will get into the details a little bit later. But by default or typically for each block, there will be a mapper associated with it. And that mapper could be on the same node where the data is existing, unless and until there are some issues handling that situation. For example, if one of the nodes are overloaded, there could be a mapper on some other node. For example, M2 to which processes the block 2 might be created on the other node also. But typically, it will try to create the locally. A map task will be tried to create it locally where your data exists. So here M1 is the mapper which will be processing data which is on block 1, M2 for block 2. Similarly, M3 on this node itself, and M4 on this node itself. For block 5, again M5, block 8, M8. For all these things, it except the block 2, it is trying to process the data on the same node, and that is called as data locality. Okay, when it comes to mappers, while it tries to execute a logic to process some data, the highest priority will be to execute with the data locality, to create the tasks on the nodes where the data exists. Okay, so in this case M6 and M7. So there are 8 mappers to process 8 different blocks. All the mappers are executing leveraging the data locality except for this one, except for block 2. I just mentioned this because there could be a probability that some of the blocks can be processed by mappers on other nodes. So there is a question: how many mapper could run in a single data node at a time? It depends upon the capacity. I will get into those details. You have to again get into the configuration and understand how the mappers and reducers are configured, and I will cover that little bit later. Here we will focus on the programming. Okay. So now, as the data is being processed locally, there are certain things which you can do in the mapper, and certain things which you cannot or should not do in the mapper. So what are the things which you can do in mapper? Because you are trying to read each block at a time, and we are trying to get count by suite. Okay, suite are diamond, club, etc. So there could be diamond cards in this block, there could be some diamond cards in this block, there could be some diamond cards in this block, and the cards which have diamonds can be spread across multiple blocks. Excuse me. In the cluster. So you cannot actually group and do the count within the map function itself, even though you are trying to process the data in each individual block. You cannot globally do the count using the mappers. Okay, so when it comes to mapper, the logic which you should implement are these ones. I'm opening another file here, new. Okay, now let's say again I have to change the marker. Sorry, I should not use the marker. Okay, now let's take the example of one block and one mapper. Okay, here you the cards are divided into rows. Each card is one row. The first one is color red, sweet, diamond, and pip. Red, diamond 3, red, diamond 4, so on. So there will be n number of cards in each of the block. So when we actually try to process the data, we will give the file format as part of the logic while processing the data. Typically, it is called as text input format. Default is text input format. And based upon the input format you specified, the framework decide to read data in a specific manner. And that implementation is already provided by the MapReduce, MapReduce classes, which are part of the jar files. Okay, the default is text file. In the text file, each record will be passed as input to the map function. So typically in the mapper, what we will do is we will try to read one record at a time. The record can be one line or it could be multiple lines also, but in this case, it is typically one line. Okay, and when the record is considered as one line, and we want to do certain row level transformation, that logic should be implemented in the map function. So in this case, we want to do the count by suite. Okay, so we have to pass this record one at a time, and we have to extract the suite, and we have to have a constant value 1 for each and every record with the suite as key. So for this record, as part of the map function, the logic should be to extract the suite, which is nothing but the diamond, and assign a value 1. Okay, for this record, so that is the logic we should implement in the map function. And for the next record, diamond 1, this is also diamond. Input is this record, and output is this one. Okay, so the map function should have the logic of parsing one record at a time, and already there are some APIs which will take care of it for you. One of them is text input format, which will read one line at a time, and the map function will be invoked for each of those lines. And as part of the map function, we should have the logic of extracting the values which are relevant to do the downstream transformations. So let me show you a program to you, then it will make a lot more sense. Okay. Let me switch to the workspace here. So in the map function, typically what we'll do is we will do the row level transformations, such as filters. So if you want to discard some of the data for downstream processing, you should implement that logic in the map function. Second one is row level standardization. For example, you have data coming from multiple sources, and each source represents a phone number in a different fashion, and you want to store in a 10-digit format in data warehousing. And that transformation for each of the source has to be implemented in the map function. Okay, so those are the things which you need to take care as part of the map function: filtering and row level transformations. So here, this code is available. Okay, not this one. 1 minute. File, switch workspace. I think I need to go to my GitHub account. Okay, big data code, Hadoop. No, not this one. Switch workspace, other. So browse. Research. Okay. Okay. I will show you from GitHub account. I think I lost the actual code. So if you go to my GitHub repository, not this one. Yeah, in the code, you can go to Hadoop. You can go to NYSC and source main Java. There is a card count by speed program in this location. Okay, if you go through my videos, it will cover how to set up that environment. As part of this setup GitHub application, you will see that. Okay, so now if I go to my GitHub code and open this card count by suite, okay, so first thing you need to understand is the job configuration. So as part of the job configuration, we will tell what is the input format. And typically the input format is text input format, where each row will be treated as a record. Okay, so and in this case the map function will be invoked one for each record of the input data. So in this picture, if there are 100,000 records in this block, for this block this map function will be invoked as part of the map task m1 100,000 times. For each input record, the map function will be invoked once, and whatever logic is defined as part of this function will be executed against this. So in this, what I'm trying to do is I'm trying to apply the logic of split function to split the record which have the pipe as delimiter, and then extract the second field, which is nothing but the suite. So the data set which will be passed as input will have color as the first column, second column will be suite, and the third column will be pip. Okay, and then I'm actually hard coding the value 1 here. So what is this text? What is this long writable? What is this mapper, etc. are nothing but APIs under the package called org.apache.hadoop.mapreduce. Okay, so mapper is a class under org.apache.hadoop.mapreduce.mapper, and it has a map function, and we have to override it as part of our custom map function. So I have written a card count by suite mapper by overriding the map function, which is part of the mapper. And here we have to tell what are the types of parameters or what are the type of variables which will pass to the map function. So the first one is input key type. The second parameter is input value type. So what is input key type? The key is nothing but the line offset for each and every record. So with the text input format, so the way it will treat the text input format, for example, we have this file. Okay, so every line will have the line offset. So for the first line it is 0, second line it could be the 0 plus the length of this line. Let's say the length of this line is 100. So typically the line offset will be 101 for this line. And now let's say there are 30 characters in this line. Then the line offset for the third line will be 131, 101 plus 30, which is the length of this line. So like that, for each and every line, there will be a line offset which will be maintained internally. So here, the input key type is nothing but line offset. The input value is nothing but the record. And these are defined by the whatever input format we define as part of this run method, which will be invoked when we run the MapReduce job. So the default is text input format. The behavior of text input format is to read each line as one record. Okay. So there are multiple things which you need to keep in mind. There are multiple moving parts. Yeah, I will get into those details about a real-time example when after I cover what is map and what is reduce and how it should be implemented for more realistic examples. Okay. So first, let us understand. Let me see about Ajay. I think he is struggling to join. Okay, so first let us forget about the programming and let us understand the MapReduce concepts in plain English, and then we'll come back to the programming. Okay, so now let's say you have a huge deck of cards. Okay, we have huge deck of cards, and there are four people or three people who want to count the cards by suite or count the cards by suite. So how it will work? Typically, we will divide the deck of cards into the number of people randomly. We will divide, and most likely it will be equally distributed. So this guy got this deck, and this guy got this deck, and this guy got this deck. Okay, and now what this guy will do if he has to count by suite. So first thing, because the cards can be randomly the cards are randomized, you get different suite every time. There is a chance that every time the suite can be different. So what this guy has to do, this guy has to take one card at a time and then divide diamonds, clubs, spades, and hearts. And even this guy has to do the same thing. D, C, S, H. D, C, S, H. Okay. So for each and every card, he has to see whether there is a diamond, there is a club, whether it is a club or whether it is a spade or whether it is a heart. And then he will group those records here. Okay, so he will divide diamonds, clubs, spades, and hearts. Similarly, the case with this guy. And now we have to get once the data is distributed like this, then there should be in the typical MapReduce paradigm. So these are called as mappers. They will get the records uh, divided and given to them, and what they do, they partition the records into diamonds, clubs, spades, and hearts, and then group the records. So all the diamonds will be one group, and all the clubs will be another group, all the spades will be another group, and all the hearts will be another group. And then there will be another character called reducer. Either the fourth person is called as reducer. What that guy will do is he will get all the diamonds from M1, all the diamonds from M2, and all the diamonds from M3. Okay, and then he will maintain his own group. Okay, so he will create a group. There will be four groups. Sorry, diamonds, clubs, spades, and hearts. Okay, and then now he has all the diamonds from all these three people, and all the clubs from all the three people, all the spades from all the three people, and all the hearts from all the three people. He will have grouped separately. Now he can count those things and give you the final result. Okay, so this is how typical MapReduce will work. As part of the map function, we will typically pass each and every record and get the whatever information we need, so that a downstream process can take care of some aggregation or join, etc. In this case, we are trying to do the aggregation by getting the count by each of the suite. But what these guys are doing, they are partitioning the data Okay, so for each and every record, they are seeing whether it is a diamond, club, or spade or heart, and they're partitioning the data. They have created 4 different partitions, and then they group them. So all the diamonds will be together, all the clubs will be together, all the spades will be together, and all the hearts will be together. And the typical, so there is a customized way which is a lot more efficient, but the typical behavior is these guys do not do any count. They will just group these diamonds, clubs, spades, and hearts and pass it on to a fourth person called reducer, and that guy will first collect all the diamonds from each of the person, all the clubs from each of the person, all the spades and all the hearts, and then he will perform the count. So there is a concept called combiner which will fall in between, which will simplify the process, but this is the typical process. Okay, now there are multiple terms which you need to understand. One is partitioning and grouping, which is happening in this phase, aggregation here, and here you are doing transformations, row level transformations. Okay, so row level transformations is for each and every record we are extracting some information. Now let us understand how it is represented in the MapReduce framework. Again, don't get into too much about the programming. The same thing, if when it actually runs in the form of MapReduce, what will happen? Okay, so I'm opening another whiteboard. Why it is giving the smaller one this time? I don't know why it is giving the smaller one. I need the bigger one. I have to increase the size. 3,600, 1,800. I don't know why it is giving the smaller one, even after increasing the size. Don't save. File new. Interesting. Suddenly, I don't know why it has changed. Let me do one thing. Let me quit it and start it. No. I don't know why it has changed the size suddenly. And even if I give the higher size, it's not picking up.
Zoom
What is
Zoom
that?
percent is only 25 now. It is.
What is that? I didn't get you.
I think you did not zoom it.
No, no, it's not about Zoom. Anyway, let me see. Typically, this is the one which we mentioned about the size, and it should take care of it. I don't know why it is. Anyway, that's fine. Uh, there should be a way to expand this one. Anyway, I will figure it out later. Okay, so here, so now let us talk from the MapReduce perspective. Again, don't get into too much of programming details. As I mentioned to you, the file will be divided into blocks. So this is block 1, this is block 2, and this is block 3. And it has bunch of records. Okay, and then you have the map task. Typically, each map task will be associated with one block, with each of the block. Okay, so what this map task is nothing but a JVM, and depending upon the framework and the logic you have implemented, by default it will treat the input as text input format. So the map function will read one record at a time. So what this map function will do is, for each input record, which is nothing but your color, sweet, and tip, for each input record, as part of the map function, as I have shown here, the logic will be to get the information you want. So in this case, I just want to get the sweet and some value, okay, and that value is 1 because to get the count accurately, we have to add those ones down the line. Okay, so if you go back to my previous picture, what I have explained that the data will be partitioned and grouped. Okay, and before, if it is manual effort, you cannot extract the sweet and then give one and then maintain it. You can only partition it and group it. But as we are doing programmatically on a data which is in files in HDFS, now we can actually process the data and we can extract and we can store the information that is relevant for us. So in this case, the input records are like this: color, sweet, and pip. So we have to extract the sweet and some value associated with it, so that we can partition and group, as I have explained earlier. So what this map function will do is, the map function will only, for each input record, it will try to create a tuple like this, which is nothing but sweet and some value 1, so that we can add these ones to get the count later. Something so similar is the case with each and every record, heart, etc. Even M2 will do the same thing, D1, heart 1. For each and every record, it will try to get a tuple like this. And even from the third mapper also, well, when it is executing in parallel, this one also will do the same thing. Okay, now once once it extracts the information, so we have applied the transformation already to get the information we need. Now we have to partition and group. So where it will happen? So there is a phase called shuffle and sort in the MapReduce. Okay, and the shuffle and sort will take care of partitioning, grouping typically. So typically it will take care of partitioning and grouping. How the partitioning will happen? So in this tuple, this is called as key and this is called as value. Okay, and as part of the shuffle and sort phase, what will happen is, for each and every record that is emitted as output from the mapper, it will compute the hash value. Hash value is nothing but integer. Even though string is the key, internally it will compute the hash value for that key, and then it will apply a mod function. So if there are 2 reducers which want to process the data, it will apply mod 2. If there are 3 reducers, it will apply mod 3. So let's take the example of 2 reducers in this case, which are ready to process the data, R1 and R2. Okay, so what it will do is, it will apply the mod function, and based upon the mod function, with the number of reducers after computing the hash value. Let's say for diamond, hash value is 1, for sweet, hash value is 2, for heart, hash value is 3, sorry, for spade, heart, and club, hash value is 4. So for each diamond, and we have to apply the mod function with 2, which is nothing but number of reducers. So 1 mod 2 will be 1. Okay, and 4 mod 2 will be 0, 3 mod 2 will be 1, sorry, 2 mod 2 will be 0, and 4 mod 2 will be 0. So for spade and club, the hash mod function will return 0. For diamond and heart, the hash mod function will return 1. So based upon that logic, it will try to partition this data. So internally, for each mapper, what will happen is, there will be shuffle and sort phase for each and every mapper. Even though I draw a large rectangle, it will happen at each and every mapper. So for map 1, the data will be partitioned into 2 groups here. So the first group will have diamonds and hearts. and the second group will have clubs and spades. Okay, so the partitioning and grouping will happen at the shuffle and sort phase after on the mapper output, and that is, you don't need to implement that logic most of the times. It is taken care by the framework itself, but sometimes you have to tweak it to change the behavior of partitioning the data, which I will not get into too many details here. I'm taking the simple example where we are applying hash mod 2 with a number of reducers as 2, and for each mapper, data will be divided into 2 partitions based upon the hash mod function. In this case, diamond and heart is the hash value of diamond is 1 and heart is 3, and 1 mod 2 is 1 and heart 3 mod 2 is 1. So the first partition will have diamonds and hearts, which generate the same hash mod 2 values, and the second partition will have clubs and spades. Okay, and also it will actually group. So it not only partitions the data, it will also actually group. What does group mean? In this case, all the diamonds will be together, all the hearts will be together. So it will look like this on the mapper output. On the mapper output, okay, data is partitioned. All the diamonds and hearts for each mapper output will be grouped and will be part of one partition. All the clubs and spades will be grouped under one partition, and then the values will be like this. All diamonds will be grouped like this, and you will have tuples grouped together, and hearts also will be like this for each mapper. So this is with respect to mapper 1. Even mapper 2 will have the same thing. So now the data is grouped and partitioned on the output generated for each mapper. Now going back to this picture, the same thing will happen with mapper 2, mapper 3, and what reducer will get is, it will get the diamonds from each of the mapper. Again, there will be shuffle and sort phase for the reducers also. Okay, that's why I draw a bigger rectangle here. On the reducer side, as part of the shuffle and sort, what will happen is it will fetch all the in this case, the reducer will only process data related to diamonds and hearts. This R1. R2 will try to process clubs and spades. So diamonds are there in all the mapper outputs, and hearts are there in all the mapper outputs. Clubs will be there in all the mapper outputs, and spades will be there in all the mapper outputs. But as part of the shuffle and sort phase, the data is partitioned and grouped, right? So now this data will be pushed to the reducer, and when the reducer collects, again the shuffle and sort phase, which will execute on the reducer before the data is passed as input to the reducer, what it will do is it will convert these key and value pairs into key and array of values. So in this case, the reducer will get key diamond and array of ones like this. Similarly, heart and array of ones like this. Okay, and this reducer will get all the clubs and array of ones like this. Similarly, spades and array of ones like this. Okay, and as part of the reducer logic, we have to hold this diamond and add all the ones. You have to hold each and every key which comes as input to the reducer, and then we have to manipulate this array. Okay, so I will show you the code example for this also. So this is how it works. So for each and every input record, the map function will be invoked, and whatever logic you have implemented as part of the map function, for each and every record, it will be executed. The logic could be filtering or transformation, such as extracting the relevant values. In this case, for each input record, I am not doing filtering at all. And then I am actually extracting the suite and associating a value 1 so that I can add those ones to aggregate later. Okay, so the output will be, for each and every input record, there will be a key value tuple. Okay, and as part of the shuffle and sort phase internally, these key value tuples will be let me. Yeah. So the key value tuples will be partitioned and grouped like this, and the logic that drives the partitioning and grouping is driven by the number of reducers. If the number of reducers are 2, for each and every key, it will compute the hash value and apply the mod function. And depending upon the hash mod result, it will partition the data. In this case, sorry, in this case, hearts and diamonds uh, generate hash mod value as 1. It's a hypothetical number. It need not be the case really. And clubs and sweets generate the hash mod value of 0, or other way around. Diamond and heart generate the hash mod value 0, and club and spade generate the hash mod value of 1. Okay. So as part of the shuffle and sort phase, whatever the mapper generates, the tuples that are generated as mapper output, on the mapper side shuffle and sort, it will be grouped and partitioned like this. And then when it goes to reducer, okay, so it will fetch for each and every key, it will try to fetch the associated records from all the mappers, and it will generate a key and array of values. So for each unique key, in this case, there will be only 4 unique keys that needs to be processed as part of the reducer. Those are diamond, heart, club, and spade. And for each unique key, the key value tuples of which are of this form will be converted into key and array of values. So the array of values are nothing but whatever values that are emitted as part of the mapper output, which are nothing but number 1 in this case. And as part of the reducer logic, we will actually perform the aggregation by adding these values. So I will show you an example, then I will take the questions. If you have any questions, I will clarify, and we will see until you understand this one. Okay. So this is the typical behavior of MapReduce. And if we go to the program, sorry, here. So now when you try to develop the program, the first thing which you will do is you will extend your class with a class called configured, and you will implement a tool called you will implement an interface called tool. Okay, so when you implement an interface called tool, you have to override a function called run, and this run method will be executed when the job is submitted. I will come back to that in a moment. Okay, here the most important thing is as part of the run function, first we will do something called job configuration. As part of the job configuration, we will pass certain information. One of the information is number of reduced tasks. In this case is 2. And the other important information is what is the output key type, output value type of mapper and reducer, which I will get back to you in a moment. On top of these things, we have to set something called mapper class and reducer class. So in this case, mapper class is card count by sweet mapper, which is my mapper, which I have developed myself, and you can see that class here. Okay, and then the reducer class is nothing but something called long sum reducer. It is part of API, so you can see it here, org.apache.hadoop.mapreduce lib reduce long sum reducer. So as part of the MapReduce APIs, they provide some of the simple functionality already, and you can get it. You can see the source code by going to a website called grepcode.com, and in this you can actually copy paste the class name, and it will show you the actual source code of that class. Okay, so we are talking about long sum reducer, and here you can see that they are actually trying to iterate through the values. So the key is nothing but this diamond, heart, club, and spade. So this reducer function will be invoked 4 times, 1 for each suite, and then it for each key the value is nothing but array of values. So the reducer has to process those array of values. In this case, we are trying to get the sum of the clubs, diamonds, etc. So we have the logic of iterating through that array and compute the sum. And finally, we are storing the sum into HDFS. So here you need to understand that map function will be invoked once for each input record, and reducer function will be invoked once for each unique key which it takes as input. So let's say you have 1 million records in this 1 GB deck of cards, which we have started as an example. So the map function will be invoked 1 million times, but using different map tasks. It could be 4 map tasks or it could be 8 map tasks, depending upon the size of the file. But the reducer will be invoked based on the unique number of the keys. In this case, there are only 4 keys. So hence the reducer will be invoked only 4 times. But the number of rows, the number of values it processes can be significant. So in this case, for each iteration, it is actually processing 250,000 records. If it is 1 million, each key will approximately have 250,000 records. So on average, for each invocation of reducer, it will process 250,000 records. Okay. So now I will take few examples, few questions. And if you don't have any questions, then we will get into the real world examples, more relevant examples. I have New York Stock Exchange scenario, using which I can explain a couple of real world use cases also. Okay. So the first question from Shiva is, number of mappers and number of reducers need not to be equal, right? So very good question. So the number of mappers you cannot set directly. You cannot say, please execute my job with 2 mappers, or please execute my job with 8 mappers. It depends upon the size of the file. If it is 1 GB file, okay, now I understand how to zoom in. Okay, so now let me change the pointer. Let us wait until the first question is answered, because this is very important concept. We will go one after the other. Nagaraj, let me finish the Shiva's question, then ask the question. Otherwise, we will lost in the volume of the questions. It is very important. I will take my time, enough time to make sure that you all understand this one. Even though we don't get into too many programs with respect to MapReduce, the concepts are same even when we try to implement using Spark. And you need to make sure that you understand the concepts thoroughly. Even the programming wise, if you don't understand, that is fine, but the concept wise you should understand, so that you can relate between the traditional MapReduce and Spark. Okay, so the question from Shiva is number of mappers and number of reducers. Very good question. So let's say you have a 1 GB file and 128 MB is the block size. Okay, which means that this 1 GB file will be divided into 8 blocks. Okay, so block 1, block 2, so on. So typically, there are a couple of parameters which control. Okay, in taking this opportunity, I will also try to explain how the mapper, how many mappers can be run on each of the node. That is the question by Jiva earlier. So I will try to answer that question also while explaining this one. So I am going on to the lab. I'm trying to access the CloudX lab. I think it's a.cloudx lab. I'm going to Ambari so that you can check the configuration. Okay. So in this case, we have to the number of mappers and reducers are determined by the capacity we have. Okay, I'm trying to answer the Jiva's question first. So there are 2 things which you need to keep in mind. There are certain memory parameters at a yarn level. So if you click on yarn and if you go to configs, here we tell how much memory should be used for running mappers and reducers. When yarn is a generic framework, and you can run MapReduce jobs and other types of jobs also. and yarn will have node managers running on each of the node in the cluster. So we are telling that node managers can use 4 GB of memory to process the data, irrespective of the underlying framework. On each of the node, we are telling yarn to use 4 GB of memory, up to 4 GB of memory. And then at the container level, let me zoom in a little bit. At the container level, so node manager is the for each node we are saying use 4 GB of memory to process the data. And then at container level, we are saying what should be the minimum container size and maximum container size. So here minimum container size is 1 GB and maximum container size is 4 GB, which means that we can tell, we can configure our MapReduce. Now I'm getting into the MapReduce. I have shown from the yarn perspective. In yarn, there are two different things. One is at the node level, I should use only 4 GB of memory. At each container level, I can configure 1 GB to 4 GB. Okay, so yarn is trying to control at a very higher level. Now, in the MapReduce framework, we are saying what is the map memory and what is the reduced memory. Okay, in this case, the map memory is 1.5 GB. These values, 1.5 GB and 2 GB, should fall in the range of 1 to 4 GB at the container level. You should not go below 1 GB or go beyond 4 GB. So here we have 1.5 GB memory for mapper and 2 GB memory for the reducer. Okay, and on top of this, there are parameters at the cores also. So how many CPUs should be used at node level, and how many CPUs should be used at the container level. Okay, so using these parameters, it will determine how many mappers or how many reducers can run at a point in time. Okay, so that's how it will determine. I am just giving a pointer to you. There is a video on my channel where I have given more realistic example, and you have to watch that to understand thoroughly, because it will take 1 hour just to cover in entirety. So that one is called as capacity planning. Okay, so capacity planning like Pro or something. Yeah, big data cluster planning like Pro. So you have to watch this video to understand it thoroughly. But I have just given overview about how the number of mappers or reducers are determined at runtime. In the older version, Hadoop 1, we directly say number of mappers is so and so and number of reducers is so and so. And if there is enough capacity on the cluster, it will run those many mappers and reducers. Okay. So I'm sharing this link to you, so you can watch this one. If you have any questions, you can ask those questions as part of the next class. So now going to the Siva's question, number of mappers and number of reducers. Okay. So here, as I mentioned to you, we have given 128 MB as the block size. So there will be 8 blocks to this file. And if you go to Ambari, there are certain parameters at MapReduce level which have split in them. So you can search for split. Okay, for I think it will take the default values if it is not specified in the it is not specified in the parameter files, and hence it is not showing up. But you can actually search in Google. So split dot size Hadoop. Okay, means split size. Let me. This is not the one. It should start with MapReduce. MapReduce min split size Hadoop 2. Yeah. So this is the parameter. MapReduce dot file input dot file input format dot split bin size and max size. So we will search for it in Google. Okay, and you should go to this MapRed default.xml, and here we will search for it. So you have a min size which is set to 0. So this is the important parameter. When it is set to 0, it will take the block size itself. So that will actually determine how many mappers should be created. So it is 0. So in this case, the block size is 128 MB. So mappers will be created based upon the number of blocks in this case. If the min split size is 256 MB, okay, then in that case, it will try to merge or club 2 blocks at a time, and it will try to use only 4 mappers to process the data. But directly you cannot say, please use 2 mappers or 4 mappers or 8 mappers to process the data. It is all controlled by split size. By default, the split size is same as block size, and it will try to use as many blocks, as many mappers as the blocks exist to process the data. Now comes the reducers. So to determine the reducers, you need to understand the data. Okay. So in this case, we have 4 unique keys using which we are trying to aggregate the data. So even if you have a given key can be processed only by one reducer at any point in time. So if you go back to the previous picture, this one, okay, so you cannot have 2 reducers processing the same key, which is diamond. So diamond is one of the keys, and either diamond will be processed by R1 or R2. If you have 10 reducers also, only one reducer will be able to process for a given key. So as we have only 4 keys, at max we can have 4 reducers. We cannot have more than that. Even if you have more than 4 reducers, the rest of the reducers will not do anything at all. Okay. So how to determine the number of reducers? You need to understand the data, and based upon the data, based upon the output after analyzing the data, you have to determine the number of reducers. So I will give you an example here. So let's say there is a retail company which has stores in each and every state in United States. So there are 51 states in US. And the requirement is, I want to see what are my top 5 top performing stores in each of the state. Okay, so the state can be a key. As part of the reducer, I want to process within each state, and I want to rank within each state. So state can be a key. Okay, and within that key, I can get what are the top 5 stores, 5 top performing stores by doing some aggregation. So as we have 51 states, we can go up to 51 reducers. But that being said, there are certain caveats. Okay, even if you give 51 as the reducers, by default, what it will do, for each state, it will compute the hash value. Okay, and then it will apply the mod 51. There is a scenario that, let's say for state California, you get 1 or 2 as the hash value, and also for state Texas, let's say you get 153 as hash value. So 102 and 153 divided by mod 51 will be 0 only. So even if you give 51 as reducers, because you have 51 keys, there could be collision because of the result of hash mod function on 2 strings can be same value. So you really need to dig into the details and determine the number of stores or number of keys, number of reducers, so that you address the skew while processing the data. That is one issue. There could be collision of hash mod values, which can limit your capability to give as many reducers you have as keys. Take another example. You have take this another example where you don't do the aggregation, you do something else. Okay, and the keys can be huge. The number of keys can be huge. That doesn't mean that you should give the number of reducers equal to the number of keys. Instead, you need to understand the data and see that how effectively how you can process the data, and you have to determine the number of reducers after analyzing the data thoroughly. Okay, So that is one aspect of determining the number of reducers. So let me take the example of Ramesh. Ramesh is asking question privately. He says, is there a way to identify the data skew even before a MR executed? Any sampling methods? Yes, MapReduce provides the sampling functionality using which you can actually determine the skew up to some extent. But in most of the cases, if you perform analysis on the data, you will understand that. For example, take the states itself. You will know each state how many stores you have. California might have a lot more stores than North Dakota, South Dakota, which are very, very small states. So you will be able to identify, and you can actually customize the partitioning logic. You don't need to go with hash partitioning itself. You can customize the partitioning logic by overriding or by extending the partitioner class, and you can tweak the logic so that you can address the skew. In most of the cases, a typical data analysis will give you the solution to determine the number of reducers. Okay, so the Ganesh question is MapReduce relevant only when writing to a HDFS, or is it also relevant when reading data from a HDFS? So I don't understand that question, Ganesh. Here, when you implement the MapReduce, it will read the data from HDFS typically, and it will write the data back to HDFS. So first you need to copy the data into HDFS if you want to process the data in HDFS. Okay, and then you write typically you write the output to HDFS. Again, if you want to get into too many details about how it works, you have to go to my videos. Don't worry too much about it at this time. Just remember that yes, you read the data from HDFS and you write that data into HDFS typically, but you can there are multiple interfaces where you can read the data from database and write into database. You can read data from any other source, process the data using MapReduce framework, and write it back to whatever target you want to. Okay. So now let me give a couple of real world examples. Nagaraj have asked one question: where is case logic addressed? For example, I want to count pip greater than 4. So this is nothing but the filter logic. Okay, so the filter logic should be applied on the map function itself. Okay, so you want to discard 2, 3, and only process from 4 through 10 and JQK and AS. So you should filter as early as possible. Okay, if you are applying partitioning, you should plan in such a way that you partition your data before processing the data, that all the 2s and 3s go into one directory, all the 3s go into other directory, all the 4s go into some other directory, and then you discard at the file system level itself that I don't want to process the directories which have 2 in them. So you have to give the naming convention also similar to that. And then you can prune those directories out. You discard those directories. You don't even need to submit the data into the MapReduce framework. But in some cases, if the data gets into MapReduce, all the filtering should happen in as much of filtering should happen in the map function itself. So it's a best practice in any project. You should do the filtering as early as possible in the execution life cycle. So either you have to take care of partitioning, you have to implement partitioning and discard at the directory level itself. Otherwise, you should filter out in the map function. Okay. So now let me take a realistic example than the deck of cards. Okay, again, I'm going back to my GitHub code. Okay, in my GitHub code, under NYSE itself, there is a directory called NYSE. I will cover that, Raj, in a moment. Let me finish this. So when you want to, I will take the example of top 3 stocks by volume. Okay, before getting into the details about the logic which I have implemented, let us understand how the data looks like. Okay, if you wanted to get the New York Stock Exchange data, you can go to GitHub account, instead of going to code repository, go to data repository, and there is NYSE here, and there is a tar file here. You download this data repository and go to this location and untar this NYSE data. Okay, and here I have already done that research data. There is NYSE directory here, ls-ltr. There is NYSE data.tar.gz here, and then I run ls-ltr, and there are 5 files: NYSE_2009, NYSE_2010, NYSE_2011, 13, and 14. As the file name suggests, each one is having the data related to that particular year. Okay, and then if you get into the file, the data is comma separated, and first one is the stock ticker, second one is the date on which the stock is traded, and then there are 4 prices. One is minimum price for the day, or open price, close price, minimum price, and maximum price. So these 4 fields are those ones, and the last one is volume. Okay, if you go a little bit so first is holiday, so you see volume is 0. Now you go to the second, and here you can see these 4 prices are different. I think this is open price, this is high price, this is low price, and this is closing price. Okay, and this is volume. The last value is volume. So in this case, the problem statement is get top 3 stocks by volume. So I want to get the top 3 stocks for each day by volume. I think I need to see whether it is for each day or for each month. I do not remember. I think it is for each month. So each month I want to see what are the top 3 stocks. Yeah, per day actually. What are the top 3 stocks by volume per day? Okay. Here the input data looks like this, and we have to process this data. So first we need to pass this, extract the date and volume. Extract the date, stock ticker, and volume, so that we can determine what are the top 3 stocks. Okay. So here the starting point is the driver. Click on the top 3 stocks by volume driver, and here to implement any MapReduce function from the programming perspective, you have to extend a class called configured and implement an interface called tool. Okay, and then you need to have the main function, and in the main function you have to invoke tool runner.run, and you have to tell which driver program you want to execute. So this is the program which I want to execute, and it has to extend configured and implement tool. So when you invoke the run function using tool runner, when the job is submitted, I will demonstrate as part of the next class. I will explain the logic as part of this class, but in the next class I will actually demonstrate this one and explain a little bit in detail from the execution perspective. For today we will only cover programming perspective. Okay, so when we actually say tool runner.run and give the class name or object name here, and arguments are the arguments which are passed for this program. We are just passing those arguments without manipulating those things. We will get to those details, what those arguments are. So the question is, in the main function, if there is exception thrown on a particular record, will the execution continue from the next record? You have to handle that situation. Either you can raise an exception and fail it. If the if that can be discarded, you have to implement that logic as part of the map function or reducer function wherever it is relevant. Okay, so in the main function you don't understand data yet. Here we are only telling which MapReduce program or which application we should invoke. We are trying to invoke the application called top 3 stocks by volume per day driver. And as part of the run function, we are configuring the job. Okay, what is the mapper, what is the reducer, etc. So the first main thing is mapper class and reducer class. So the mapper class is nothing but top 3 stocks by volume per day mapper, and reducer class is top 3 stocks by volume per day reducer dot class. Okay, and these two are implemented by me only. And let me go back here. So as part of this package, NYSE package, NYSE top 3 stocks by volume, I have a driver which I have shown you, I have a mapper, and I have a reducer. So as part of the driver, we are doing some manipulation at the directories, which directories should be processed and which directories should not be processed. If you go through my videos on this program, you will understand. Again, it is part of MapReduce playlist. I will give you the link in a moment. So here, we are just trying to understand which directory should be, or which file should be processed, and we are discarding the files which we are not interested in. Okay, and then mapper class is top 3 stocks by volume per day. There is a question from Raj. I will come back to that in a moment. And in this, what I am trying to do, I am actually, so by default, we each record will be treated, or each row in the file will be treated as one record. So in this case, this one will be treated as one record, and I am passing that record. So the key for this map function is nothing but the byte address of each record, and the value is record itself. So I'm passing that record as a string into a function called parse function. So there is a program called NYSE parser, or Java class called NYSE parser, where I have getter and setter methods, and it is part of a package called NYSE parsers. So I'm going back to that here. NYSE, there is a parser. So for the data, first we need to write the parser, or you have to parse it as part of the map function itself. But it is better practice to have the parsers separately. So as part of this NYSE parser, what I have variables. So these variables are nothing but, or attributes are nothing but the number of fields in this data set, which are 7. The first one is stock ticker, second one is trade date, third one is open price, high price, low price, close price, and volume. Okay, and then the record is passed to the parse function here. As part of the, I am creating a NYSE parser object, and then as part of the map function, I'm actually invoking the parse method of the parser. So parser is nothing but a variable here, and I'm passing the record as a string to this one. And here I am setting these attributes. Okay, so stock ticker is the first field, trade date is the second field, open price, as the data is in string, I'm typecasting to float and storing it as float. For volume, which is of our interest, we are actually converting into long and assigning it to the attribute volume. And then there are getter methods and setter methods, which we can use as part of our program. Once the parse is done for each and every record, the parse function is applied, and then there is a key, which is a custom key, long tail primitive, because I'm trying to get top 3 stocks by volume for each day. Okay, so I need to get the date and also the volume, so that I can sort the data in descending order by volume and get the top 3 stocks. For that, I have created a custom key called long tail primitive. It has 2 methods, set first and set second. The first key is date, and second key is volume. Second value in the key is volume. So this is key, and the record, the value that is the output of the mapper function is nothing but the entire record, which is nothing but this one. Okay, that is the mapper logic. We are extracting the date and volume, And then because I want to get all the details of the top 3 stocks, that's why I'm passing on the entire record as the value. So if you go back to this picture, here the tuples are nothing but key and value. I will come back to that question, Raj. You have a couple of questions. I will respond to that in a moment. So in the cards example, the key is nothing but the suite and the value is 1. Whereas in this example, the key is a composite key which have date and volume. Okay, and the value is nothing but the record, because downstream I want to get all the details for each of the record. That being said, let me take the couple of questions here from Raj. Can you please tell me about job context and job class? So let me finish this. I will come back to that in a moment. Does the mapper write to HDFS? It can write. If you can run map only jobs, and in which case you can actually write the output to HDFS from the mapper also. So if you have map only job, the context.write will directly write into HDFS without writing into shuffle and sort phase. If you have a MapReduce job where you have reducers downstream, instead of writing into HDFS, it will write into intermediate files, and the output from the intermediate files will be passed on to the reducers, and reducers will process that data. So the second question is answered. Job and job context I will cover a little bit later, probably as part of the next class. Okay, so this is our output. So output of this mapper is nothing but a key value pair. The key is a composite key. It has trade date as the first element of the key and volume as the second element of the key. Now going back to the driver program. We have the mapper class, and we understood the logic of mapper, and we have the reducer class, but in between there is something called partitioner, grouping, and sorting. Okay, so I have explained that the partitioner logic will actually compute the hash value and then apply the mod function. In this case, the mod function will be applied with the number of reducers 6 here. But the key is a composite key. We have both date as well as stock ticker. Sorry, not the stock ticker. Both date and volume as part of the key. Okay, so and we want to get top 3 stocks by volume for each day. Okay, so let me whiteboard here. So for a date, okay, so let me take the no, not the marker, round tip pen. So the keys will be like this: 2012 01 02 stock ticker A, sorry, volume. Let's say it has volume of 1000, and second record have for the same day the volume of 1100. Okay, so I have explained that it will take the entire key. The default behavior is it will take the entire key, compute the hash function, and then apply the mod logic. Hash function, and then apply the mod logic. In this case, mod will be 6. So the hash value of this one is different from the hash value of this one. So when the partitioning happens, this record will go to a different partition, and this record will go to a different partition. And if that is the case, then we cannot group and we cannot actually get the ranking so easily. It is not possible. For that reason, we have to write a custom partitioner. We should not use the default partitioner. Instead, we have to write the custom partitioner, and the logic should be all the records for a given date should go to one partition. Okay, so we have to extract the first key and compute the hash value of the first key itself. We should not include everything. So here, if you go to this class, first key long pair partitioner dot class. For that, we need to understand the package. It's written by me again. The first key long pair partitioner. It's under partitioners package in NYSE. So I'm going there to NYSE, go to partitioners, and here I'm invoking this one, first key long pair partitioner. Okay, the reason why I'm using long pair partitioner is, you can see here the map. This is the mapper logic. Here I am using the long pair primitive as the type for my output key of the map function, and the output value is of type text. So this is of type text, and this is of type long pair primitive. So for that reason, I am using the first key partitioner, which I have developed on long pair primitive. So that is the logic which is here. So in this, I am extending a class called partitioner, which takes the long pair primitive as key and text as value. And in that, I'm applying get first function on the key. So long pair primitive get first will get only the first value from the key, which is nothing but the date in long format, which is YYYYMMDD. So 2012 0102, and then I'm converting it into string and getting first 6 values, converting into long value, and then I'm actually doing mod function on the long value of the date. Okay, so for each of these keys, I'm getting the first element, and then I'm applying the mod function on it directly. So even when I actually create the key, I discard the hyphens and I'm storing it as long itself. Okay, and now taking that long value, using the key dot get first, I'm converting into string and get using substring to get first 6 characters, because it has actually I'm partitioning in the form of a month, I guess. Yes, I'm actually partitioning from the month perspective. Okay, and instead of doing at the date level, I'm doing at month level. Okay, so that I can actually partition by each month. If you want to do it by date, you can do it by date also. Okay, so this is my partitioning logic. So there is a question from Nagaraj. Let me take that question. Where are you defining the get first function? So here there is a class called long pair primitive, and this long pair primitive is under package NYSE key values. So this one will have the get first, get second out of this paired key. So the naming convention is long pair primitive is I am creating a key of type which have 2 objects, sorry, two attributes in that, which are of type long primitive data type. Okay, so this will have the get first function, and I am here the key is of type long pair primitive, and when I apply get first function, it will invoke the get first function in this long pair primitive. If you want, I can show it here. NYSE, it's under key values. So long pair primitive. So this is the get first. Okay. So now, so now we are using the year and month to partition our data. So when the data is partitioned using year and month, all 2014 Januaries will go to one partition, all 2014 Februaries will go to one partition. And as part of the framework, it not only groups, but also it will actually sort the data. So even though you have 2014 Januaries partitioned as part of the logic, they will not partition randomly. Instead, they will be grouped and they will be sorted. So all 2014 Januaries will be grouped, and when you actually look into the data, for the first record by default will be from 2014 January 1st First few records from 2014 January 1st, second few records will be from 2014 January 2nd, etc. So the data will be sorted automatically in ascending order. But how the data will be sorted? We have the composite key, we have the date, and we have the volume here. Okay, so if you see, even the grouping comparator, I don't want to group by entire key, rather I want to group by the date itself. So if you go to the grouping comparator logic, my grouping comparator is long pair primitive grouping comparator. The package is NYSE comparators. Again, these comparators, partitioners, etc. are part of the shuffle and sort framework. You can tweak those things to change the behavior. If you want to master them, you have to take the complete course by going through my videos, and you can use this code as reference to learn it quickly. I don't want to get into too many details at this time as part of the course, because our focus is primarily on Spark. Okay, here I'm using long pair primitive grouping comparator. So if I open this one, even though the data even though the data have keys, in this case I want to group based on the first element only. Sorry, even though our keys have composite values where you have both date and volume, I want to group all the records with respect to date as one group, and otherwise it will again take the hash value of the complete record, and it will try to group within that using those hash values. Rather, what I'm trying to do is I'm again extracting the first element from the composite key, and I'm trying to group based on the first element. Here I'm not doing any transformations, I'm directly using the first element. So automatically, when the data is sorted, when the data is stored, it will be stored, it will be grouped on the date, in this case 2012 0102, and then the first record will be 1000 by default, and the second record will be 1100, and it will be in ascending order based on date as well as volume. So the least volume record will be the first one, and the highest volume record will be the last one. Because of the grouping comparator, the default behavior will be like this. The grouping is happening only on the first element. But to get the top 3 records, we have to sort the data in ascending order or descending order by date. It doesn't matter, but by volume it should be in descending order, so that we don't need to process the entire data. After getting first top 3 volume records, we can discard the rest of the stuff if the data can be sorted in descending order before giving it to the reducer. Okay, for that reason we have to tweak the sorting comparator. That's why we are implementing sorting comparator as part of our program. If you go to the driver, you can see I have the grouping comparator and I have the sort comparator also. And the sort comparator is long pair primitive sorting comparator, and that one is this one, long pair primitive sorting comparator. And here you can see the first one I am comparing in ascending order. It doesn't matter. Okay, so this compare function will actually determine whether the data has to be sorted in ascending or descending. So in this case, I am directly comparing the first elements in the key. So by date it will be in ascending order, but the second element I am changing the logic so that we can actually get the data in descending order. So the output of this is, after the shuffle and sort, when the data goes to reducer, what will happen is 2012 0102 will be the key, and for that key the values will be in descending order. Okay, so let's say the first 3 elements are here. Now when we actually implement the reduce logic, we can process up to this one. Once we get the top 3 volume, we don't need to process the rest of the stuff. Even if we have millions of records, already data is sorted in descending order, we just have to process subset of data and ignore the rest of the stuff. For that reason, we have to change the sorting order, and for that, I am implementing the sorting comparator when it comes to MapReduce implementation. You should not write the complete sorting logic or grouping logic either in mapper or reducer. It's not a good practice. Sorting, grouping, partitioning should be taken care by shuffle and sort phase, but you should have enough knowledge to tweak it if you want to be a Java-based MapReduce developer. If you don't want to be, you can ignore these things. But for those who already have the Java, it's worth exploring these things, understand the APIs, and try to write a little bit complex MapReduce program so that you get mastery on it. Okay, now I'm going back to the program, and then we have the reducer class. The reducer is nothing but top 3 stocks by volume per day reducer. Okay, here I'm going back to the NYSC, and we are talking about top 3 stocks by volume, and go to the reducer. And as part of the reducer logic, I'm actually crossing only first 3 records. Okay, so here I am actually handling a situation if there are no trading happened. If all the records are having 0 as volume, that means the first record will be 0. So we can discontinue the iteration and move on to the second date. And in the second date, if the count is less than or equal to 2, we are trying to get only those 3 records, and we are trying to store that information in the output directory. Otherwise, we would like to discard. Okay. So like this, you can write more complex use cases using MapReduce application. In this case, I am using the sparse ranking. So if there are 4 records which have top 3 volume, still I will be preserving only 3. If I want to implement dense ranking, it is a little bit more complicated. I have to keep track of the top 3 volumes, and then as long as all the records of those top 3 volumes are processed, I have to iterate through, and then I have to discard the rest of the stuff. That also can be implemented easily, but I didn't get into those details. So go through these things so that you have better understanding about the MapReduce APIs. As part of the next class, we will try to run a couple of programs and see how it actually executes. In that, you will understand from the entire execution lifecycle of a MapReduce program as part of day after tomorrow's class. So if you have any questions with respect to programming, let me know. It's a little bit complicated for non-Java developers, but people should have at least basic understanding of it. That's why I have thrown examples such as word count as part of my website, and I have explained the cards as well as little bit more example, little bit more complex example here. So now let me look into these issues. The first issue is from Shiva. Sir, while running word count program, getting exception. Could you please check it once? I will come back to that. In the meantime, you can paste the exception here. Let me take care of Srinivas issue. Not able to install STS in Windows. So what is the error you are getting, Srinivas? You can share your screen. I will make you the presenter.
I don't have a JDK thing. First thing, okay, I downloaded the JDK.
Okay.
Here I can share the screen.
Okay, let me make you the presenter. You can share your screen and you can actually explain what the issue is.
So I have installed the JDK 32 version. Okay.
No, don't install 32 versions. You have to use 64-bit versions. Otherwise, you will run into issues later. Okay.
Once I have done this STS bundle. unzipped it.
Okay, have you set Java home?
Pardon me?
Have you set environment variable Java home?
No.
Yeah, you have to set the Java home. First of all, discard these things. Is your operating system 64-bit or 32-bit?
64-bit.
Yeah, so discard these things, uninstall JDK, go for 64-bit, and also set up
Okay.
STS with 64-bit. So the missing point is Java home. You have to set the Java home. You have to set certain environment variables. And once you set those environment variables, it should be fine. And I hope you know how to set up the environment variables.
No, those things I'm not aware.
So the way you can do the environment variables is if you can share your give me the control, I can explain how to set the environment variable.
How to do the control.
So on the top, you will have assign, and after that assign, there will be an icon, I think share or something. In that you have to share the keyboard and the mouse control to me. After assign,
Right?
yeah, share, and then you will have keyboard and mouse control.
My screen. To you, right?
Yeah.
So shared it, then where is it? Assignment. Okay, sorry.
Keyboard and mouse control.
Keyboard and mouse control to. Okay.
Okay. So the way you have to set the environment variable is okay, here actually you can search from here. Control panel.
Okay.
Go to control panel, and here okay. And actually you can search for environment variables. Yeah, so directly you can search for environment variables. Click on this environment variables. I don't know, it's not working. It is frozen. I think as I'm doing remotely, it is not working. Yeah,
Okay.
you can click on environment variable now,
Yes, I click it.
but it's not coming up. Yeah, it's coming up. So now if you scroll, if you go down, you means on top you have users variables, and bottom you have system variables. Okay, in the system variables, you have to create a new variable by clicking on new, and you have to create a variable called Java underscore home, all caps, all caps. Okay, and then you have to give the directory path where your Java is installed. So the directory path could be, give me the control. No, don't create it now. After setting up JDK 64-bit, then you can do that.
Okay.
So click on cancel. I will show you how which path you should give.
Sign to. I think.
Yeah, let me see. Yeah, I think I have the control. Okay, so you have to go to the this PC, C drive, program files. So as you install the 32-bit, it's under x86. x86 is 32-bit. Java, JDK. Okay, so this is your Java home.
Okay.
Okay, so you have to copy this path and you have to paste in the value.
Okay.
And then the way you should validate even before doing STS is go to command prompt and run Java version
Okay.
and hit enter. So it is working actually. It is identifying where the Java is. So it could be some other issue. Anyway, you do it with 64-bit, then I will troubleshoot the issue if it is not working. Okay.
Okay.
Okay then. Always make sure that you use 64-bit unless and until it is not available if you are using the 64-bit operating system. There are several issues which you need to understand. If you are using a 32-bit application, okay, that 32-bit application cannot use more than 3.4 GB RAM.
Okay.
Okay, even if you have a 64 GB machine, your application cannot use more than 3.2 GB RAM, and that case it will start crashing and there will be many issues. And on top of that, for Hadoop, you always should use 64-bit only. You should not use 32-bit at all. Okay. So now let me let me make the Shiva presenter and let us troubleshoot his issue. Shiva, you can share your screen.
What do we do? Let's
Yeah.
stop it.
Yeah. You can share your screen and I can troubleshoot your issue. Hello, Shiva.
Okay.
Yeah, you can share your screen and show me what the issue is.
Okay.
I've given control to Shiva.
Yeah, Shiva, you have to go to the quick start and you will see the share screen option. You are now
I've shared.
okay. Yeah, I can see now.
As you have suggested in video, I have copied that form.xml and have copied the code. Just I giving input. This is where I have this what count text value.
Okay.
And
Okay.
count
Before getting into this, are you logging in as guest or are you logging in as your own user?
own user.
Okay, okay. So let me troubleshoot. I understand the problem. Even I think someone else also, Gyan Prakash also ran the same issue with respect to Windows. It is working for him on Mac, but he got the same issue with respect to Windows. So let me troubleshoot this issue.
So one more thing is there is no error in the form.xml, but when I click on this Maven install, one as Maven install, it's showing like no JRE for compilation.
Okay, let me see. So right click, run as, Maven install. Yeah. So one issue is you are using J2ESE 1.5.
I have changed it to 1.8.
1 minute. Let me troubleshoot the issue. Yeah, so you are running a JRE rather than a JDK. So you didn't set up Java JDK. You are using JRE. Okay. So first you need to fix that. And properties compiler. You have to install JDK. Do you have JDK on your machine?
Yeah, I have that 1.8.
No, still it is showing as 1.5 only.
have changed that to 1.8, but it's not.
Yeah, that's what. There is some issues with your project. Let me see. Properties. Okay, remove old version in the build path.
Above it, above. Build path.
It's already there. Let me do this. So run as Maven clean. Okay. Run as yeah. So what Ramesh is saying is to delete .m2 completely. I'm not sure whether it will fix the issue or not. Okay. Okay. I think there are some permissions issues on our machine. So let me do this. Close the Sigwin and then
Yeah, it's 1.8 version. So can you click on this window, STS of navigation?
1 minute. 1 minute. Which window?
On the STS tool, the top side there is run the help window.
1 minute. 1 minute. Let me try doing this. Yeah, see here it is saying read only. I don't know. This Windows is click on OK, and if I see properties again, see it is again changing to. So there is some issue with this setup. Okay.
Ramesh has suggested something.
Yeah. I will check that. Advanced. He is saying to go to advanced. Okay. Okay. Okay, I got it. First, let us see whether this will work. Could not find or okay. Okay, so now let us see. Run as Maven install. This also might fail.
I am changing that to JRE to JDK. It's showing the tool cut the last time marking graph.
Yeah, so I have recorded a video on that, and let me share.
As for that, I have created a list folder and I have copied that to the list folder tool cut.
So is it working or no?
No, it's not.
Yeah, then you are not doing properly. Okay, let's first resolve this one. It will work because it is tested on Windows also, and Gnan Prakash was able to compile after making that change. But when I change it to 1.8, it's not even changing this DRE system library to 1.8. So we need to check that. Remove the extra JDK default Eclipse pointer in. Okay, let's wait until this is downloaded. I think it will take some time because you are in India. The download might be slower. Okay. What is the issue you have solved, Ramesh? Okay, okay. So where is it, extra JDK? We cannot hear you, Ramesh. Build path, okay. So build path, configure build path. From the libraries, this one? Okay, now build path, configure build path, add library. Okay. I think 1.5 version is uh, 1.5 version issue is gone. So let us see the once the downloading is done, if the issue will resolve or not. Others can drop off. If you guys already set up the environment, you guys can drop off. I will not cover anything after this. So let me troubleshoot this issue. If you want this, you can actually watch the video later also. What have happened? Yeah, I think there are no errors at this time. Form.xml also looks everything good, but still build have failed. So let me see what is the error. Okay, still it is complaining about the JDK instead of JRE. Okay. Anyway, okay, Maven is installed with 1.5 version. Okay, let me do this. Let me again try running as. So the same issue. MEN version. No, Ramesh, Maven is pointing to 1.8 only. Anyway, you can have a look at this later, Ramesh. You can drop off. I will try to help him as much as I can. Otherwise, I will point him to you. Okay, so here again it is complaining with respect to the same thing. Properties. Do you have JDK at all on your laptop? Okay, let me see that. See. And also let me search for the environment variables. Can you click on the environment variables? Okay. Yeah, you can. I can see it is JDK. Yes, Ramesh, it is 64-bit. You can cancel it. Cancel it. And go to this one. Remove this one also. Add library. Here you can only add JRE. Next.
Then here I can select that ADK path.
Where?
You close this window, sir. Now go on to that window, top corner, navigation here.
Here.
File edit source refactor.
Where is that? Okay, okay. Refactor navigate. Okay.
Window.
Okay.
Differences.
Okay.
Here, you can choosing that JDK path instead of this JRE 1.0102. Then I am facing that tools that are error.
Okay. So how are you choosing that? Can you can try adding that now? JDK 1.8.
Okay.
I don't know. I never ran into these issues. Somewhere you miss the order. No, that is JRE home. How can you set the JDK home to JRE home? Okay, paste it. Let's try.
In Stack Overflow, they are suggested like
Okay. Yeah, you have to enable this one.
now if I run as manual install, it's showing the tools that
1 minute. No, see the issue which I have demonstrated is if it will come in the POM itself. So if it is giving in the Maven install, then it's a different issue altogether. Okay, you are trying to apply a different solution for different issue. Run as Maven install. Where you don't have the tools here. Ideally, it should have been here.
there is dot have
Yeah.
to understand.
1 minute. Where is your tools.jar? I couldn't find.
In Java folder, Java.
Yeah, see, that's the issue. You have to understand it properly. So the way it is showing up is, it should be here.
Continue.
Okay, you can see here, it is saying Java JDK JRE and then dot dot. So JRE dot dot is nothing but here, up to here. And then you need to have lib directory, and then you have to have tools.jar. Okay, but still, let's see. Run as Maven install. It might compile this time. I'm not 100% sure, but let's see. Yeah, it is moving on. Okay. Now the build is success, but I'm not sure whether the program will run. Let us see. Run as run configurations. Yeah, still the program is not running. Let me troubleshoot the issue from the program perspective. Run as run configurations. Arguments. Okay, so EITVST big data. It's CD IP varsity. Okay. Okay, the location is correct. Okay, let me try to do one thing. Let me copy this one to C directory. Paste. So still it is complaining the same thing. Okay, see big data properties, security. What the heck is going on?
There is some checkbox. Edit and user.
Yeah, 1 minute. Okay. What is that? Edit?
Yeah, below there is checkbox, right? Apply these permissions to objects.
That's fine. That is not the. Okay, let me try something else.
We have moved that to C drive, sir.
So I have copy. I haven't moved. So still it is the same issue. I don't know. I have to troubleshoot the issue. I will have a look at that. As you are in India, I will follow up with you once the issue is fixed, and then I will take care of it. Okay. Okay, then thank you very much for everyone for joining the session. Have a nice one. Bye.